Question 3. No calculator. And for each of the following, write answers as fractions, simplifying as far as possible. Blaise Pascal was a French man who lived in the 17th century for 39 years, making many contributions to mathematics and science. Calculate the number of words that can be generated by the letters in Pascal. So if we think about Pascal, 1, 2, 3, 4, 5, 6, we have 6 letters, but we also have 2 A's. So we have to use 6 factorial for the number of possibilities, but dividing by 2 factorial because of the letter A repeated twice. So if we had a calculator, we could use that. Now by hand, 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1. Now the 2's can cancel, so I'm thinking we can say 30 times 12. So we have 30 times 12, which is 360. So there are 360 words. If there was not a repeated letter, it would just be 6 factorial. Because the A repeated twice, we have to divide by 2 factorial. A part 2. Calculate the probability that a random word with the letters in Pascal would begin with the letter C. So there are 360 possibilities. Some of them start with the letter C. Let's have a think about that. It would be C and then 1, 2, 3, 4, 5. The other 5 letters would be, so really it's C and then a word with 5 letters. How many words have we got there? Well, it's 5 letters, still with the 2 A's coming within those 5 letters. So that's going to be 5 factorial over 2 factorial as the number of 5-letter words coming here. So that's going to be 5 times 4 times 3 times 2 times 1 over 2 times 1. The 2's would cancel. 5 times 4 times 3 is 60. So the probability is going to be 60 words starting with C out of 360 words. 60 out of 360. 6 out of 36, which is 1/6 as our simplified fraction. 1/6 of all those words in A part 1 would begin with C. What about beginning with the letter A? So one approach would be to say that 60 of the words start with C, but also by sort of symmetry or whatever, starting with S, 60, and P and L. So that is 4 times 60, which is 240. So 240 start with C and S and P and L. The rest start with A. 360 minus 240 is 120. So the probability that it starts with the letter A, this random word, is 120 out of 360. Cancel. 12 out of 36, which is 1/3. A third of those words would begin with the letter A. Mariam Mirzakhani was an Iranian mathematician who lived for 40 years in the 20th and 21st century. At the International Congress of Mathematicians in 2014, she was awarded the Fields Medal for her striking and highly original contributions. B. Calculate the probability that a random word from the letters in Mariam would not begin with the letter M. So, first off, M-A-R-Y-A-M, it's 6 letters, but there are 2 M's and 2 A's. So, that means we would have 6 factorial over 2 factorial, 2 factorial, which is 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1, which is the same as we had before, and 2 times 1. So what we could do is the answer from above was 360, but we got to divide by an extra 2, 180 is the number of words. Right. If we took, for example, the letter Y, 1, 2, 3, 4, 5, Y has words beginning with Y, that would be 5 factorial over 2 factorial, 2 factorial, which is 5 times 4 times 3 times 2 times 1 over 2 times 1 and another 2 times 1. So really it's the same as above, but divided by 2. So above we had here 60. So now we're going to have 60 over 2, which is 30. 30 of the words start with Y. 30 start with Y. So also we can say they would also start with R. So that's 30 and 30. 180 minus 30 minus 30 is 120. So there are 120 words either starting with M or A. So if we divide that by 2, 60 start with M. We want words not starting with M. So we have 180 minus the 60, which are the M words. That leaves 120. So our probability is 120 out of the 180, which is 2/3. Okay.